In section 2.3, we're going to spend a great deal of time talking about graphing. We're going to talk about the XY coordinate system, and you should all know what that looks like. We've got my X and my Y coordinate system. We're going to be dealing with ordered pairs. We're going to be dealing with something that looks like this. We're going to create a table where this is X and this is Y. And we're going to define the X side and define the Y side. And we're going to use these terms right here to explain to you what is taking place when you put values in the X and the Y. We will, for the most part, use the equation or the ordered pairs -1, 0, and 1. Those are the only three that we really need. We'll adjust that slightly, but for most of the discussion, we'll talk about those three numbers. They're significant because they are easy, and they're in order, and they will include what is called the y-intercept. And so just get familiar with those three numbers. Use those about 99% of the time, and when there's a difficulty and maybe those numbers don't work as well as they should, then we'll discuss that, explain what numbers might work better, and then plug those into the equations. So get yourself ready to understand X and Y axis. We're going to be dealing with graphing, and we will discuss these terms very specifically. What a mapping is, what a set is, a relationship or just a relation, input and output, a function, domain and range, scatter plots, and vertical line test. We'll also probably use the terms independent and dependent. You might want to add that to the list here. And all of that will be discussed at length and completely as we go through this particular section. We first begin by talking about something known as a mapping. It's represented like this, with these two ovals and numbers in between, or numbers in the left-hand side and numbers in the right-hand side. On this one over here, you might want to consider something like this, and we talked about this being X and this being Y. There's a possibility that the things on the left are the X values and the things on the right are the Y values. Mappings, as it says right here, mappings represents two sets of objects or items. And so here we have the two sets of them, and the arrow from the left-hand set pointing to the right-hand set represent a relationship or a relation between the two items. And so what we're going to be dealing with is looking at these to see if they create functions or are not functions. We're going to give you a definition and explain to you how functions work and how non-functions work. So these, you can just read them and see what the ordered pairs are. This first one is 1, 7. The next one is 2, 1. And then I'll let you finish the others. Down here they want you to create a mapping. So you're going to draw two ovals like this. Put 5, 11, 6, and 8 in this one, and 8, 9, 8, and 5 in this one. I'm sorry, the first numbers go here, the second numbers go in this one, and you should be able to create your ordered pairs and your mappings from them. The word set. A set is a collection of numbers, geographic figures, letters, or other objects that have some characteristics in common. That is a set. So if I put the numbers down 1, 2, that's a set. They have something in common. They happen to be ordered pairs. And that term ordered pairs will be used a lot in this particular section as well. So a set is a set of numbers that are a lot alike. I could create a set of 1, 3, 5. I can make a set 2, 4, 6. Those are all sets. They also happen to be sequences, but those are sets. They have the same characteristic. These up here are all odd numbers. These down here are all even numbers. Here's our first look at the terms input and output. And I'm going to do something here on the input. I'm going to put an X above it. And on the output, I'm going to put a Y above it. Now, I'll let you fill this out. If this is X, tell me what it is over here. And if this is Y, replace the Y with the proper word. I think one of the best ways to describe this input and output is to relate it to something that you're familiar with. You all know what a remote control is on the TV. Well, some of you girls don't because it's a man's thing, and your brother or your father always has the remote. The remote is the input. You push buttons on the remote, and through an infrared signal, it's picked up by the TV, and either the volume goes up or down, or you change channels. That's the output. If you play video games, the game controller in your hand is the input. What you see on the TV or the computer or wherever it is you're playing, that's the output. So you're very familiar with input and output. You use it all the time. Well, the input and the output put together is a relation. It's a set of ordered pairs or a mapping between the inputs and the outputs. And so we have right here a relation. We have here a relation. As a matter of fact, I could circle every one of them because they are all a relation. They make an ordered pair. The first coordinate is called the input, and the second is the output. They have other names as well. Down here you see the words domain and range. So if I draw this little thing here, I label this X and Y, here is my input, and here's my output, here's my domain, and here's my range. Sorry, didn't leave enough room there to type it or to print it. So my domain and my range. Get used to those terms. We will use them all the time. We will use them interchangeably. However, when I use the word input, the word output is associated with it. When I use the word domain, the word range is associated with it. We would not say domain and output. That wouldn't make any sense. A function right here maps each input to one and only one output. And we'll show you a problem when we start dealing with functions. When something goes to more than one output, you'll find out that it is not a function. So here's an example of something that is not a function. We have on the left-hand side the domain, or the input portion, the numbers 1, 2, 3, 4, and 5. On the right-hand side, or the output, or the range, we have 1, 3, 5, and 7. And notice in the mapping that we have, on the left-hand side, 1 goes to 1, but 2 goes to 2 different outputs. 3 goes to an output. 4 and 5 go to the same output. I think there's a problem with the number 2 on the left-hand side, or the input side. In our previous definition, it has to go to just one output, and this is going to 2. It's going to 3 and to 5. If we were to graph this equation, or these ordered pairs, you would see that it does not work out to be a function. Let's see if we can do that here quickly. And we'll just do it freehand, if you will. 1 goes to 1, there's one part. 2 goes to 3, but 2 also goes to 5. 4 goes to 5, and 5 goes way over to 7. I didn't leave enough room. If I connect this up, however, to there, this part right here is not a function. Go to here, that would be a function. This first part's a function, but that part that I have circled is not a function. Now, I wish I could draw a better straight line, but understand they are straight lines. And that part is not a function, and we'll explain why in just a little while. But can you see the difficulty? If one output or one input goes to two outputs, it's not going to be a function. So here we just start now to look at problem number 2, and we're going to read each scenario and decide whether or not it fits the definition of a function, and then right here explain your reasoning. Yes it does, or no it doesn't, is not sufficient. Yes it does, and tell me why. If it does, you ought to have something like, because each input goes to one and only one output. If it's not a function, then you can say one input is going to two outputs. Something like that. Write down what the problem is. This just continues on, so there's not much else to say here. Okay, here we're going to start analyzing sequences, and I think I mentioned to you earlier that I'm going to play something for you, and I'll do that before we begin this section, talking about a very important sequence, the Fibonacci sequence. But what they want you to do here is just determine whether or not this thing is a function or not a function if you follow this sequence. So the first one, 2, 4, 6, 8, 10, 12, 14, I think you can figure that out. 1, 0, 1, 0, 1, 0, 1, 0. And this one, 0, 5, 10, 15, 20, 25, 30. Are they functions? And what do you notice, and what conclusion can you make about these sequences? Here we're going to analyze a graph and determine whether or not it's a sequence. What I suggest you do here, and I'm not going to do it for you, but what I suggest you do here is start with that very lowest point that is at 1, 1, and draw lines to connect the points. You can draw them in any order that you want, but if they let's see, how do I want to say this? No, I'm sorry. Don't draw them in any order. That was a mistake. That's why I can't think. Draw them in sequence. Go from 1, 1 to 2, 3 to 3, 1, and then to 4, 1, and see what it forms. In B down here, start to draw them, and you can see there's going to be an issue right there. Okay? So this is what I referred to earlier. Here is something that is called the vertical line test. The vertical line test says simply that if you can draw a vertical line on a graph and it crosses the graph in one place only, then it is a function. If it crosses it in two places, then it is not a function. And it has to be, this vertical line can be drawn anywhere, but has to be drawn in such a way that it will indeed cross if it's supposed to. So if I draw this kind of a graph and I put this on it, can you see this vertical line right here? Crosses it in two places, but so does that vertical line. Right here, this is a vertical line. The reason it's not a function is it not only crosses it in more than one place, it crosses it everywhere. So the vertical line test, very important for you to remember that. We will use that often. And you don't have to draw the line. You can just visually see it. If you can see that the line is going to cross in two locations, you don't have to draw it, just say it's not a function. So I'll let you examine these and determine whether they're functions or not. Okay, different kinds of equations make different kinds of lines, or graphs, I should say, not just lines. And so one of the responsibilities that we have is to try to determine what kind of line or what kind of graph is being created by each of these equations. And so what I'm going to plan to have you do here is that we will use the graphing calculators, and I'll show you how to put in an x squared, and I'll show you how to put in the absolute value into a graphing calculator, and you can determine whether or not they are actually functions. Here we're going to be doing some cutting and some organizing, and it wants us to place these graphs in either a function or not a function categories. By the way, these are referred to as function families. We want to put them in families, those that are functions in one family and those that are not functions in another family. Now go ahead and do the talk the talk. It just answers some really important questions. There's only these two problems here, so go ahead and do the talk the talk. In this particular section, we're going to talk only about linear functions, those things that make a straight line. We've seen this equation before, y equals mx plus b. When we talk about functions, we replace the y with something like this. F of x equals mx plus b. Now, I'm cautioning you right now, don't get hung up with the f of x. It just isn't that important. F of x and y are the same thing. There's some different notation and connotation, but for our purposes, all we're interested in is in you understanding that if y equals mx plus b, f of x equals mx plus b. So here we have our first assignment here, first problem. You're rock climbing a vertical cliff. It tells you it's 108 feet tall. You've been climbing for a while and are currently 36 feet above the beach. When you stop to have a snack and begin climbing again, you can climb about 12 feet in height each hour. If you maintain your pace after your break, how high will you have climbed in 1 hour, 2 hours, etc.? This is just plugging things into the formula. You've got a situation where you need to create the equation that's going to look like y equals mx plus b, and plug these numbers in that are in the problem. Okay, here we are back to a table using the information that you just gathered. Here's the input and the output. You know that you're going to have minutes or hours in the quantity name and the unit of measure. And what the output is going to be in feet, miles, whatever. Create an x and what you're going to do to that x. So this is going to be an x right here. And what are you going to do to that x to get this column filled out? You'll take the information from the previous question and then just answer these here at the bottom. Now we're going to graph this thing. They've already labeled this thing for you and have made it 1, 2, 3, 4, 5 up to 15, and then 10, 20, 30, 40, 50 up the left-hand side. Just for your input information, this is input and this is output. This is x and this is y. You can already see that there. Okay? So when you create your table and you start putting things in, there's x, there's y, input, output, and plug the numbers in to the left-hand side, you'll get them in the right-hand side. Okay, big definition time. A function whose graph is a straight line is a linear function. A linear function is y equals mx plus b. I want you to remember that equation. You will use it over and over and over.
I'm going to forego all the privacy of doing this all on my own and hope that you might benefit from the experience of watching me as I import these pictures, get them organized, and publish them to the cloud. And now, because this